Right, yeah. I was just wondering if she's going to do it with her being in JO and stuff. That'd be good. Good training race, I guess.
Yeah, no, I think so. Yeah.
Is this one of the races that your old student who's like now a really good skier in? The one you talked about at that academic?
Oh, actually,
Like, is he still skiing or no?
you know, he isn't doing much skiing anymore. The one that wasn't very good, he'll be doing it.
Okay.
Yeah, he actually places pretty high in it. He gets, 1 year I think he was top 30 out of 8,000.
Yeah, my answer is completely wrong.
It's not a bad place to be.
Yeah.
That's not bad at all.
See you later.
Right,
See you, Aaron. How are you in this one?
What do you mean? What's a D? 60 to 60.
Yeah, this curve would not. Hey, Eric, we saw you all on the camera.
I know one of you ahead of time.
Yeah.
If I lose.
We were watching him just towards that, and when they had dancing,
No. If I win, I will take it.
Did you go? If I had to do it, I probably would be wearing it. Why do you feel the need to try and kill each other? There does not have to be any pain in the high five.
That's what you always say. It's always like that way.
Because that didn't war.
How do we just not have war? Because I mean, war is all about killing people. So, but there's nothing to do war.
War because not
No, seriously.
who is left.
Pretty awesome. There's no people here.
Oh, yes. Okay, so no award?
Yes. No one was ever worried.
So I'm sorry.
No prize for you.
Aggressive debate.
Sam,
You just watching the pigs today.
watching the what?
Watching the pigs.
Going to the boxing room.
Watching that pig.
Last game.
In all the hiding waters.
See that fewer lives.
Eric's back!
My blood pressure would probably drop to half of what
How was it? Are you going to
Oh my God, Charles, I love your pink stuff. And the library is so do stuff. Yeah, which is amazing because I had this staff project. And I was like, I'm going to send to school today.
Eric! Yeah.
But I got all my graph stuff and I got all my outliners. And I had to outline.
Horrible! I was the only one in the farm. Like, me and Eric just chilled out. We were just making fun of that. It was fun. I should have done stuff, but she would do that too. She's like, I'm going to do it in school. Yeah, I mean, I'm just gonna wing it. Because, like, history's the first subject, like, my thing. Like, you know how we had that, like, DQ thing? I did it in 1 hour, literally. No, there was no one. It was like 8. Yeah, it was just like 8 steps. And I was like, one person in the whole. I'm just gonna wing it.
Yeah.
Pretty tardy for history, right?
You
know, apparently I cut like 5 classes about it.
Like, for example, one of the tops of the Bible.
How was
Actually, the government
Were you at the game? Wow, how'd you get the extra pass? Huh? And they left right away, or bang, bang, bang? Okay. So what did you do? Wait till the third period to score the second, third goal?
Well, the last goal was over net. That's what it is.
So it was close then. Lee scored the first goal,
He
huh?
scored the first goal. I just scored the next
I see shots on goal quite a few. They just couldn't get there. The goalie was good.
And also they were like the players were watching. That was like the goal. Keep it serious.
Plus or minus are the 8 line.
That's everything you probably have a little more time.
I wasn't here tomorrow. So just gonna play on my
Yeah, well, I guess.
You're still missing. We're trying to find somebody to do up. And then just both get all together and be like, okay, so I'm not going to never finish. Rachel is sure.
Yeah, Rachel.
Yeah, she's constantly like so. It is though. Silly Rachel.
Yeah, I'm so stupid. Why did I do that?
So it'll be 8 o'clock tonight.
That's old news, huh? Miss Lake would like the boys ski team go to school on Tuesday and get recognized. So I said that'd be good. So it's at 6:30 Tuesday. PM. The district's going this week, and I'll be there. And it's like at 6:30, like just meetings and say we'd like to recognize the state champion. So he's down to the team. We'll try to get over there. They kind of fun to be recognized in the sport. Okay. Okay, Sam is not here. BJ.
Well, this is based off of the second half.
I literally read through chapter 5 and it's just so it's really great. I mean, at least we get to revise it. Probably just like family. I'll just add like a few sentences or paragraphs. Oh wow.
Alright, so like mental what it is that I actually hate the X-rays. So I think it's stupid. But the other thing is like, for example, I think the best like flex off so the way that's for us it was more just like which sounds like
There are always empty seats around.
Okay. like to register that she was smart. I'm telling you, we're gonna. So I'm gonna.
Eric.
All right, good afternoon, folks. Welcome here. You non-hockey fans, you?
Yeah, we must do some first.
Was it the actual broadcast of the game?
Yeah.
Okay. I mean, it came through okay? Yeah, we had some issues in there. Today, instead of a joke, we'll have a definition. Definition of heroes. Definition of heroes. Definition of heroes. It's what a guy in a boat does.
Why does it have to be a oh? So it doesn't be a guy. It doesn't realize that it was don't understand. That's the best thing to do. I was just trying to break down some gender barriers.
Okay, today we're going to move on to vectors. Vectors as functions. And if a vector is a function, then we can take the derivative of it and we can take an integral of it. So, if you define a function, a vector R as some function little I plus some function g little j. Of course, what do I and j stand for? The x and y direction, they're the unit vectors. So basically, this is a vector that goes this much in the x direction, it goes that much in the y direction, and those are unit vectors. Well, the definition is, if you take the derivative of this with respect to t, you simply take the derivative of this with respect to t times I plus the derivative of g with respect to t times j. So it's really pretty simple. All right. Now, one more definition, and we'll do some examples. R equals a position vector. So if R is a position vector, that means it tells you a certain spot. If you take the derivative of it, what are you finding?
The speed.
No, you're finding you're close. Someone said it. The velocity is equal to the velocity, which would be that. Now, let's do your question, or your answer. What is the magnitude of the velocity? That is the speed. Okay? And what do you suppose the velocity divided by the magnitude is?
Acceleration.
No,
No, direction.
that's the direction, because you're taking the velocity, dividing it by its magnitude. That gives you the unit vector, which is basically the direction that the vector is going in units. All right, so how do we define velocity? Velocity is speed times direction. And now just put these two together. Speed is the magnitude. The direction is the vector, unit vector, which is v divided by the magnitude. And of course, what happens? Magnitudes cancel out, and you get the velocity vector. Okay. Now, the rest is easy. As long as you know calculus. And of course, we already know calculus, so we're good.
Oh, no. 2/3. Then we all
What? What? All right.
I'm gonna have a tune now.
Okay.
I'm a tune here.
You can take multivariable counts.
But not at a high school.
No, we don't have it.
Unless you like that.
I thought of it, but there's just not enough. Up to this point, there hasn't been enough people to do it. Now we're getting that point in mind. Okay. Not at high school.
Well, if you put the course proposal in next year, I will be on the district advisory committee.
But it wouldn't be, it'd be for the following year.
Yeah, but I can push us out.
Okay, here we go. R is the position vector. What is the velocity vector? The velocity vector is simply the derivative of the position. So all you do is take the derivative of each of these components. Derivative of 3 cosine would be negative 3 sine of t, I, and this would be plus 3 cosine of t, j. What would the acceleration be? The acceleration vector is simply the derivative of the velocity. So that would be negative 3 cosine t I plus minus 3 sine t j. And so if t is pi over 4, which means we're dealing with a right triangle, what would the position be? Its position at pi over 4 would be 3 cosine pi over 4i plus 3 sine pi over 4j. And what's the cosine of pi over 4? Cosine of pi over 4 is 1 over root 2. And so this would be 3 over root 2i. And what's the sine of pi over 4? Same thing. So 3 root 2j. So that would be its position at pi over 4. What would its velocity be at pi over 4? Well, its velocity would simply be this one here, negative 3 sine of pi over 4i plus 3 cosine pi over 4j. And pi over sine of pi over 4, 1 over square root of 2. So this would be minus 3 square root of 2i. And cosine, this is also 1 over square root of 2, so plus 3 over square root of 2j. Okay? What is its speed? Its speed is the magnitude of the velocity. So you take your velocity vector, which is right here, and you calculate its speed, which would be the square root of the component squared. So negative 3 square root of 2 squared plus 3 over the square root of 2 squared. And that would be 9/2 plus 9/2, which is 18/2, which is the square root of 9, which is 3. So it has a speed of 3. What is its direction? Its direction is its velocity vector divided by its magnitude. So in this case, it would be what? Here's your velocity vector. We're going to take this and divide it by 3. So negative 3 square root of 2 divided by 3 would make it negative 1 over root 2 I plus this divided by 3. Why don't I write the whole thing so it makes a little more sense? Basically, you're taking minus 3 root 2 divided by 3 I plus 3 root 2 divided by 3 j, which becomes negative 1 over root 2 I plus 1 over root 2 j. Yes?
On the AP exam, would we have to rationalize that?
No. No rationalization is needed at all. And I don't know why they do that in pre-calc. Because everything we do in calculus is ratios. You know, what's the slope? The slope is up 1 over the square root of 2. We'd rather see it as a ratio, not as a rationalization. So, in fact, leave it as square roots in the bottom. Okay, a question on that? All right.
Why do you feel the need to rationalize?
What?
Like, why do you like? It just,
The reason you do it in pre-calc is the square root of 2 is a decimal that doesn't end. And so you're dividing by a number that doesn't end, which in some senses it doesn't make sense. It's not a rational number. That's why they do that. But in calculus, we're looking at ratios and proportions and rate of change. And so I think it's more important to just leave it. Okay? Okay, second part is doing integrals. So let's just jump to that. Definition. A vector. If you've got a vector defined and you want to integrate the vector with respect to t, you simply integrate each one separately. F of t dt times I and g of t dt times j. That's all there is to it. And keep in mind, when we're doing vectors, it's just another way of doing it. You could do it with the coordinate system, but it allows in some certain situations to make it easier. So let's do a simple example, and then we'll do a little more complicated. Let's integrate 0 to pi the cosine of ti minus 2tj with respect to t. So all you have to do is find the antiderivative of each one separately. Antiderivative of cosine is sine. So you're taking sine of t, you're going to evaluate it at pi and 0. And then it'll be times I. And then we go minus the antiderivative of 2t, which would be t squared, evaluated at pi and 0, times j. Okay. So you're going to end up with the sine of pi minus the sine of 0, all times I. And you're going to have minus pi squared minus 0 squared, all times j. All right, what's the sine of pi? What's the sine of 0? 0, so that means there is no x component in this vector. And here you're going to have minus pi squared times j. So it's basically minus pi squared times j is the vector that you get when you integrate this method. Okay? Okay, let's make a little tougher example. Let's say the velocity vector is 1 over t plus 1I plus 2tj. T is greater than or equal to 0. Its position is r equals the natural log of 2I when t equals 1. Find its position at any time t. Alright, so you're told its velocity is this, its position is this when time is 1. What is its position at any time?
Wait, is that supposed to be natural log squared or natural log of 2? Natural log of 2.
Natural log of 2. I think that's all I want. Yeah. Okay, so if we're trying to find its position, we need a function with position. How are we going to get that? The antiderivative of this, so velocity can be rewritten as the r dt, and that's going to equal 1 over t plus 1I plus 2tj. All right, that's a differential equation. How do you solve differential equations? Separate the variables. So we put all the dR's on this side and all the t's on this side. So essentially you rewrite it dt. And then you integrate. So we integrate both sides. The left side, of course, is vector r. The right side, 1 over t plus 1. It's always complicated looking, and if I put it 1 over x dx, you can say it real easy. It's a natural log. So 1 over t plus 1 would be the natural log of t plus 1. So it's the natural log of t plus 1 times the I vector plus t squared a vector plus
C.
a constant, because we just integrated an indefinite integral. All right, now how do we find C? By going back to your initial conditions. The r vector, which we have, is going to equal this when t is 1. So anytime you see a t, you put in a 1. We're going to log of 1 plus 1 I plus 1 squared j plus c. And it has to equal what? The natural log of 2 times the I vector. Okay? So what's C? Negative j. Because these two are going to cancel. And then you're going to have j plus c has to equal 0. So c is a negative j. So now our position vector, r, is the natural log of t plus 1I plus t squared minus 1 all times j. You want to consolidate things, put them together. You could write t squared j minus j, but you just put it all together and make it t squared minus 1. All right. So there's our vector that gives us any position at time t. And lastly, find the distance the particle travels from 0 to 2 seconds. So we're doing the same problem. We're just finding the distance that it travels. Okay, now you have to remember, what's the formula for finding distance? Well, we have a vector, and the vector is in parametric form, because this is the x component. So what does x equal? Natural log of t plus 1. This is the y component, so y is the t squared minus 1. So now, distance that a particle travels is equal to what we did, remember? To find out, see, basically what you have is you have a vector r, and then it moves, and then it moves, and it moves, and we want to know how far it's traveled. Well, what we did is we took a little segment, found its distance, another segment, and added them all up. So we had to integrate to find out what all those little segments added up. So it was an integral. And what's the length of each segment? It's, okay, let's say I want to find the distance from here to here. Make it like this. The distance from there to there, I had to take a little triangle to find this distance. And this length was dx dt, because it's changing with respect to t. This is dy dt. And this is the distance. So how do we find out d? Square root of dx dt squared plus dy dt squared. And so that's what we put here. So we go dx dt squared plus dy dt squared dt, and we're going from 0 to 2 seconds. Okay, is it all kind of making sense? All right, so now we're integrating from 0 to 2, square root dx dt. That's the derivative of this component, which would be 1 over t plus 1 squared. And then the dy dt is 2t squared. And I think that's as far as you have to go by hand. And then this would be roughly 4.335. I guess this was in meters. I didn't really stress it at the beginning. Okay. And of course, note that dx dt and dy dt were simply the derivatives of the position here, which was the velocity. You know, so to to find a distance, you just simply integrate the velocity over a time period. Okay? Okay, I went a little fast. Hopefully it wasn't too fast. But I just tried to keep it quick. So that was today's lecture and tomorrow. Okay, just go come up with a long one.
So does that mean we have a day off tomorrow?
Well, I don't have a day off, just have a day to work.
Oh.
I mean, you know, you can do what you want, but I'm going on the schedule. I'm spending 2 days in each section, so then come Monday, we'll start 10-4. I'll spend 2 days on 10-4, 2 on 10-5, 2 on 10-6, and then review, and then test. Okay.
Are you sure you don't want a 10.3 right now? You don't want a 10.3? Okay. Mr. Keeper?
What do you need? 10-3? Okay, you know who takes them? My 4th hour PC people, the 8 people that are taking, that have it the 4th hour. I will, I'll get some. No, okay, what do I do? Find She literally wasn't trying.
I
guess I could ask him questions.
Yeah.
The last one was just because they were careless. Like, you know, the goalie comes out, they're really sloppy or something.